Our last system of measure in the customary system is going to be the customary system of capacity. Just like with length and weight, we utilized a chart to answer even difficult questions in a snap. We will do the same thing for capacity. So again, go back to that paper, find a rectangle where you have not yet written, and go ahead and quiz yourself on your knowledge of creating that capacity chart. When you're done, resume the video and let's see how you did. Now, whereas with the length system, there are 4 different units of measure, and the weight system, there are 3 different units of measure, we know that in the capacity system, there are 5 different units of measure. We list them from least to greatest. And that's the way that we start every chart. Fluid ounce, cup, pint, quart, and gallon. We create those arrows so that we can use this like a map to build our numerical expressions for conversion. We know that when we go from fluid ounce to cup, we're going to divide by 8 because when we go from a smaller unit to a larger unit, we divide. The relationship between ounces and cups is that it takes 8 fluid ounces to have a cup. The relationship between cups and pints is 2. There's 2 cups in a pint. There's 2 pints in a quart, and there are 4 quarts in a gallon. To go from a larger unit to a smaller unit, we multiply. So here we're going to multiply by 8, multiply by 2, multiply by 2, and multiply by 4. And with that, we have created our chart that we can utilize for any question. Let's go ahead and jump in with a question and use our chart. This one says, Max has 18 cups of lemonade. How many gallons is that? So with this, the first thing that we have to do is decide what is our given measure. Our given measure here is 18 cups. And we can see by analyzing this question and its key details that we want to take it to gallons. We're given 18 cups, and we want to know how many gallons that is for the lemonade. So we go back to our chart. We are starting with 18 cups. This is my starting point. But I want to know how many gallons are in 18 cups. I can see that there are multiple conversions, multiple steps that I have to do to go from cups to gallons. I'm going to need to divide by 2, see how I can utilize my chart like a map. I'm going to need to then divide by 2 in order to find out how many quarts I have. And then the last thing I'll have to do is divide by 4. So as I build my numerical expression for this conversion, I'm actually going to have to take my 18, divide that by 2, divide that by 2, and divide that by 4 in order to find out how many gallons we have in 18 cups. So let's jump in and go ahead and begin with our problem solving. The first thing that we do, this one is just a basic fact. It can be done in our head. 18 divided by 2 gives me 9. I know that there are 9 pints in 18 cups. The next step is to take, so here we have done this part. The next step is to take our 9 and divide it by 2. Now 9 does not divide by 2 evenly, so this is a good opportunity to practice utilizing our discussion on sharing the remainder, using the remainder to create a fraction, which is a good part of our 5th grade math division standards. So we know that 2 goes into 9 4 times. 4 times 2 gives us 8. Our remainder is 1. Now we can utilize that remainder and turn this into a fraction. What's on the bottom of my problem, the remainder, flies to the very top, and my remainder becomes my numerator. My divisor becomes my denominator because this is one of the 2 that it would take to create another digit or another number in our quotient. So with this, we have found out that in 9 pints, there are 4.5 quarts. We have utilized, or we have solved to find that 18 cups equals 9 pints and it equals 4.5 quarts, but we still have this additional step to get to gallons. I need to take my 4 1/2 and divide that by 4. This is another good opportunity to practice our fraction computation that we have worked so hard on. We know that the very first step of fraction computation is for division as well as multiplication, is to turn it into all fraction form. We do that by multiplying the bottom and add it to the top. 4 times 2 gives us 8 plus 1 gives us 9, and our denominator stays the same. So 4 1/2 is equal to 9/2. Now I'm going to turn that 4 into all fraction form by putting a 1 underneath it, because 4 wholes is the same as 4 over 1, or 4 wholes. Now, since this is fraction division, we're going to use our trick of keep, change, flip in order to turn this into a multiplication problem. I keep my 9 1/2 the same. I change multiplication, or excuse me, I change division to multiplication, and then I flip or invert 4 over 1 into 1 over 4. Now that I've done this, if I could cancel at this point, but there are no shared factors that are a good pair, one from the numerator, one from the denominator. So instead, at this point, I simply multiply my numerators and multiply my denominators. When I do that, I have 9 times 1 gives me 9, 2 times 4 gives me 8. Now, this is an improper fraction. An improper fraction has a numerator that's equal to or greater than the denominator. I know to turn this into a mixed number, I use division. 8 goes into 9 one time with 1 left over, and my denominator stays the same. So with that, I have found how many gallons are in 18 cups. I'm going to come back to my conversion chart, and I'm going to write this down. I'm going to write it up here just so that I can see it with this dry erase marker. And I know that 1 1/8 gallons is equal to 4.5 quarts, 9 pints, and 18 cups. So let's go back to our question so that we can answer the question we were actually asked. If our problem has words, then our answer must have words too. Max has 18 cups of lemonade. How many gallons is that? Well, we know that it's 1 1/8 gallons. That's the conversion that we were asked to do, but let's use words from the prompt to answer. Max is trying to make lemonade, or he has lemonade. He just wanted to know how many gallons that was. So let's say that Max has 18 cups of lemonade. And with that, we have given our restate, we've given our actual answer, and we have some good details of our problem solving.